Let's take a look at another example. An airplane flying at 650 miles per hour has a bearing of north 42 degrees west after flying 2.25 hours. How far north and how far west has the plane traveled from its point of departure? Again, let's start by sketching the bearing. So at this point, I know my initial direction is north. I then am going to travel 42 degrees west. And they want to know the distance west and the distance north. So what I need to do is to create a right triangle out of this direction or bearing. So I need to do the distance west and also the distance north. When this occurs, I'm going to generate a right triangle. Again, from the previous slides and previous sections, I know that when I have this north bearing and this north bearing, they are parallel. That generates two congruent alternate interior angles. So I know that this is also 42 degrees. From here, I know that I need to find my direction or distance west. I'll let that be x. And here I also need to know my direction or distance north. I'll let that be y. All right, let's set up our trig functions to solve for these two values. Well, I identify the angle, which is 42 degrees, and I want to identify the parts of the right triangle based on that angle. This 42-degree angle, this would be the opposite leg. With this 42-degree angle, this leg helps create that angle, so this is my adjacent leg. And I know that this is opposite my right angle, so I know that this is my hypotenuse. And I can determine the length of my hypotenuse from information given in the problem, which is it traveled at a rate of 650 miles per hour for 2.25 hours. Therefore, distance equals rate times time. The rate was 650 miles per hour times the time, which is 2.25. Using a calculator, I find the distance, or my hypotenuse, to be 1,462.5 miles. Then I'm going to use this in conjunction with some trig ratios and solve for my opposite leg, which is the distance west, and my adjacent leg, which is the distance north. Let's start with solving for the x value, or west. So here, I'm going to use the opposite leg over the hypotenuse, which I know is 1,462.5. So that's going to be opposite over hypotenuse, which is sine of 42 degrees. And here, that will be opposite leg, which is x, over my hypotenuse, 1,462.5. Then my solution for that would be 1,462.5 sine of 42 degrees equals x. From the calculator, my distance west is going to be 978.6 miles. Let's find the distance north. Again, I'm going to use 42 degrees, but now I'm going to use the adjacent leg and the hypotenuse. So when I use the adjacent leg over the hypotenuse, my trig function is cosine, but still at 42 degrees. Again, when I substitute in, my AL, or adjacent leg, is going to be y over the hypotenuse, which is 1,462.5. Solving that problem, 1,462.5 cosine of 42 will give me my adjacent leg, or my y value, which will be the distance north. Using my calculator, I get 1,086.8 miles north. Let's look at another problem. A boat leaves a harbor and travels 31 miles in the direction of north 36 degrees east. The captain changes direction and travels another 27 miles in a direction of south, 54 degrees east. At that time, how far is the boat from the harbor? Let's start by drawing a diagram. We initiate with a coordinate plane, and our first direction is north, 36 degrees east. Our first vector starts north, and then we travel 36 degrees east. Then we change direction, and we travel at south 54 degrees east. Another coordinate plane. South 54 degrees east. And they want to know how far we are from our original starting point. From previous sections, we know that this north line and this north line are parallel, and we have a transversal. And this angle, which is 36 degrees, and this angle, which will be 36 degrees, are called alternate interior angles. They are congruent. With that information, I know that this is my 54 degrees and 36 degrees. When I add those together, that gives me a right triangle. Let's take a look back into the problem, and I realize that he travels 31 miles in the direction of north 36 east, so this is 31 miles. I also read that he travels 27 miles south 54 degrees east. I can use the Pythagorean theorem, which is 31 squared plus 27 squared, which equals my hypotenuse squared. And then when I simplify this, take the square root of both sides, c is equal to the square root of 31 squared plus 27 squared. When I put that into my calculator, I'm going to get my distance from my original starting point, or hypotenuse, is going to be 41.1 miles.